Welcome, everyone. I am James Corsi, Executive Director of the Global Spaceport Alliance, GSA. Firstly, I want to thank Farnborough International for the kind invitation to join their Aerospace Global Forum 2022 initiative, a global platform which, as we see today, is facilitating conversations between leaders of industry, academics, government, and innovators to drive meaningful action. The pioneering spirit of the aerospace sector, and more recently, the space domain, has powered the innovation that is so crucial to ensuring the incredible growth of recent times and that it continues in the years ahead. I'm delighted to be here at the air show alongside so many industry partners, and it is a real pleasure to be able to see you all in person again after what feels like so many, many years. This week's gathering in Farnborough is a great example that by bringing the aerospace ecosystem together, we can find bold solutions needed now and in the future. The Chinese have a saying which can be interpreted as a blessing or a curse, depending on your perspective. May you live in interesting times. Well, for the global commercial space industry, we are in interesting times indeed, and I, for one, say it's a blessing. Launch services have reached a steady cadence, and in-space activities are increasing. The NASA Artemis program is moving ahead for our return to the moon, and communications, positioning, and Earth observation are all growing. Spaceports play an integral role in all four of these theaters. But there is another area of real excitement, and that is point-to-point space travel. As such, GSA is delighted to produce our special programming titled The Advent of International Point-to-Point Space Travel. The GSA is presenting this content in two taped virtual sessions for FIA attendees, along with an in-person session in the FIA Space Zone Theater. This content is central to GSA's mission. Since its formation in 2015, GSA has had the vision of creating a global network of current and proposed spaceports that can serve as focal points and technology hubs to facilitate the growth of the space economy. Over the next few years, member spaceports will evolve their operations to form a mutually supportive and interoperable global network. As such, the GSA network of spaceports will be the backbone of point-to-point. GSA has 28 spaceport members from all continents, except Antarctica and Africa. We are working on Africa. These members are spaceport operators. We also have 9 associate members who provide products and services for the spaceport operators, and 8 academic and government members. By the way, as you're watching these sessions, you should all join the Global Spaceport Alliance. So call me or go to our website for details at www.globalspaceportalliance.com. Among the many benefits of GSA membership is our annual Spaceport Summit that is co-located with Spacecom, the global commercial space conference and exhibition. It is also launching a new event, Space Mobility, which will have a defense focus and cover spaceports, launch, and in-orbit service and maneuvering as they relate to assuring access and superiority in the space domain. So mark your calendars for February in Orlando. Plus, February in Orlando is fantastic, so bring the family. Thanks to all the panelists who've assembled to address this crucial issue. And thank you once again to Farnborough International Airshow for hosting this important meeting. So now let's get started with our sessions, hosted by our GSA chairman, Dr. George Neild, who also is the former head of FAA's Office of Commercial Space Transportation. George, over to you.
Thank you, James. In addition to all of the exciting things going on right now in commercial space, we're starting to see the early stages in the development of a new class of high-speed aerospace vehicles that can travel between any 2 points on Earth within just a couple of hours. Although many different design concepts have been proposed, the ability to conduct high-speed, long-distance transportation through space, initially for cargo, but eventually for people, will be a major game changer, both for national security and in terms of how we travel, communicate, and do business on a day-to-day basis. This session is going to explore the current prospects for such systems, including both the challenges and the opportunities, and discuss how they could be integrated with the emerging international spaceport network. We have an outstanding panel that has agreed to share their perspectives, and serving as our moderator is Oscar Garcia, CEO of Interflight Global, who was the chair of the Global Spaceport Alliance Working Group on point-to-point transportation. Oscar, over to you.
Thank you very much, George and James, and to Farnborough International. It is an honor and a privilege to be moderating this outstanding panel of speakers regarding the high-speed point-to-point transportation using space as a medium. My background as a former long-haul airline pilot tells me that for the past few decades, the air transportation industry has mastered the skills of and technologies to travel long range. And today, Airbus and Boeing products can cross the world anywhere to anywhere non-stop, yet the speeds at which they fly remain the same. For the last decade and a half, I've been involved in the high-speed transportation conversation, and I'm very honored that our group is a strategic partner to the Global Spaceport Alliance in furthering this conversation. The decades have gone by, and I'm cautiously optimistic, but very optimistic, that this decade we are going to see an inflection point in the technologies and activities that will allow to make the world a 90-minute affair anywhere to anywhere. And for that conversation, the panel today could not be more exceptional, considering the background of our speakers encompass all the dimensions that could be insightful and also foresights to what's coming in high-speed point-to-point transportation. So I will start the panel discussions, and I'll introduce the first speaker, Mr. Steve Lindsay, Chief Strategy Officer of Sierra Space. I will not enter into a detailed background because we could spend the whole hour doing so. However, I'll mention that Steve Lindsay has commanded 2 space shuttle missions and been pilot of 3 space shuttle missions. So when we talk about high-speed space point-to-point transportation, I could not think of a better person to give us a crystal ball insights into the future. Over to you, Steve. It's a pleasure having you on the panel.
Well, thank you very much, Oscar. Appreciate the introduction, and it's a real privilege for me to be here today to speak on this panel about what's a really important subject for me. And so what I'd like to do is spend a few minutes and talk about Sierra Space, the company that I work for. In addition to Chief Strategy Officer, I'm also the Chief Technology Officer and involved in advanced programs and advanced development. So one of the things that I am doing is looking at the future, and that includes what does commercial point-to-point look like in the future, and it's a very exciting future indeed. So let me talk about the company a little bit and what we are doing. So we are a vertically integrated space technology company, and you can probably see on this chart that here, what our focus is we are specifically working on creating an ecosystem in space. And what do I mean? We're focused on low Earth orbit to begin with. We're creating an ecosystem which includes transportation through our Dream Chaser spacecraft and a destination, essentially a commercial replacement for the International Space Station. As many of you know, the space station will be retiring by 2030 at the latest. NASA and other space agencies want to have a commercial space station to be able to purchase services in. But we also want to grow a commercial market out there to use it. Things like biopharma, advanced manufacturing, building satellites in space, just to name a few. Even space tourism is a big part of that. Our vision of our company is really to enable humanity to begin new civilizations in space. And that's global, that's international. We specifically designed our spacecraft to be able to land anywhere in the world you can land a 737 aircraft. And that was by design because we saw, even when I got here 10 years ago, a future where that would happen. And we are actually in conversations with many spaceports around the world right now to land Dream Chasers there. So our mission is to build this platform in space to make the world a better place. And that's really what our company is all about. How are we doing that? So we are organized with 4 commercial product lines. Space transportation, which is Dream Chasers. That includes a cargo science version of Dream Chaser, which we're working on right now and intend to fly next year to the International Space Station for NASA. Space Destinations Group that's working on a commercial space station based on our life habitat that we developed actually in my advanced programs group. Space Applications, which is where we vertically integrate our products to enable our platforms to create this ecosystem. And finally, Space Ventures, because a big part of this is developing the commercial market to go with this low Earth orbit ecosystem that currently is just in development stages. And a lot of that is going to those companies that have a play in space and may not even realize they do. And so that's a big part of our focus as well. So what's our strategy? Our strategy is we're going to get there first. And we did a capital raise, and we have programs actively going on a crewed Dream Chaser, a cargo version of the Dream Chaser, and our space station as well as the vertically integrated technologies. To see that before the end of this decade, we have all of these vehicles flying in this ecosystem created. We're building this, start small, build this and expand it over time based on demand, grow with demand, but really focused as space as a business platform for businesses, not just international space agencies to do the research, development, exploration objectives, but all of these commercial entities to create the next breakthrough drug or organ transplant or something like that, or additive manufacturing in space. We're working to bring partners and providers into our system, and we're being very aggressive with that and seeing a lot of success there already. We want to provide value-added services and make sure that whatever your business is, we can enable that in space. You take care of the business side, whatever it is you want to develop, we'll take care of the space side for you. And obviously national security space, which was already mentioned, is a big part of what we're doing as well. So our company is, we are up to almost 1,800 employees now, so we've been growing very quickly. We have a significant amount of manufacturing capability. We have operational mission control centers to go where we're going to operate our vehicles from. A lot of manufacturing test spaces. We're obviously been working with NASA for many, many years and continue to do so, as well as ESA and JAXA and other organizations. Really focused on test facilities, manufacturing facilities, AI&T facilities to where we can build fleets of Dream Chasers, which is what our plan is. So let me talk about transportation real briefly. I'm just going to talk about our first vehicle, and we are in 24/7 production, 7 days a week, no holidays off, focused on getting our DC-100, which is our uncrewed Dream Chaser, built, tested, and flying to the International Space Station in 2023. So we were really focused on that. The vehicle was designed specifically, as I mentioned, with commercialization in mind. We can land anywhere you can land a 737. It's a highly reusable spacecraft, at least 15 missions. We think we can probably double that when we get the test data back. We can carry 6 tons plus up to space, obviously return it to our runway. We have a very low entry G-force as compared to a capsule, which really enables you to get sensitive science back to the Earth, or sensitive manufacturing, things like protein crystal growth, where you can bring it down in a very benign environment, land it at a runway, get it back in the researcher's hands immediately. And that's really the goal, and that's really what we designed the vehicle to do, using decades of experience on a space shuttle, taking advantage of those things that space shuttle did well, looking at the things that space shuttle didn't do so well, and trying to improve that, and obviously improving our cost to make it truly commercial. On destination side, you may have heard we partnered with Blue Origin, so we're a 50-50 partner with Blue Origin. We competed on the NASA Commercial LEO Destination Program, and we won that award. So we are working with Blue Origin to create our first space station, which we call Orbital Reef. We're providing our habitat and a node, and Blue Origin is providing core and some of the power and propulsion systems. But we're working together as an integrated team to create this business platform that I just talked about. Ours is based on the Life habitat. This is an inflatable habitat, and what's unique about it is it'll fit inside a 5-meter fairing of any standard rocket. We can launch it. When we get it in space, we inflate it. It inflates to 27 feet in diameter. And if you look at the volume of this habitat, it provides the equivalent volume of 1/3 of the space station today. So for a single launch, we can get to 1/3 of the pressurized volume of the current space station today. And by comparison, it took us 40 launches to build a space station. So we can obviously do it much more cost effectively, a lot of capabilities with this system, and we can expand it modularly as we go through. On the space application side, that's one of our verticals, one of our sectors. Their job is to support all of our products as we develop them. And so what we're involved in the application side are all kinds of things. We have a very unique solar power capability that we're basically using pick and place machines to produce solar arrays more energy dense and much faster and much cheaper than anything that's happened before. And so that business is greatly expanding for us as we speak. We have propulsion systems. We do our own rocket engines, from upper stage engines all the way to small hypergolic engines. All of the engines we're using on the Dream Chaser is done by our propulsion group. And then many other applications, the mechanical systems, we've provided components for the last 30 years on every single interplanetary mission that NASA's ever done. We do flight control actuators for Dream Chaser, and that group is really critical. And all of these groups are critical to provide the right amount of vertical integration to help us produce our products quickly and cost effectively to service this ecosystem that we're creating. So with that, I think I'll get off the stage, Oscar, but thanks for your time, and excited to visit the panel and hear some of the questions.
Thank you very much, Steve. Outstanding. You've touched on some very, very important points that we'll go over the question and answer session. You touched on reusability involving the supply chain from aviation, aerospace into space, safety, reliability. It steps towards routine, the routine we see in air transportation today. Fantastic. Thank you very much, Steve. And again, you have been there and done that. So your words are very, very important. So I'll move on to the other two panelists, and then we'll have a Q&A section at the end. Let me move on to Jess Sponable. Jess is the President and Chief Technology Officer of New Frontier Aerospace. New Frontier Aerospace is designing and manufacturing a high-speed point-to-point vehicle that flies on the verge of air and space, at the edge of the atmosphere. Jess has been part of the Defense Advanced Research Programs Agency, DARPA, as well as 30 years veteran of the Air Force. He has been part of the DCX programs, X-33, X-34, and has practical experience in actual flight tests of vehicles that are precursors to the high-speed point-to-point conversation we have today. So without further ado, I'll pass it on to Jess to give us his perspectives from the research and development of vertical takeoff and landing high-speed point-to-point. Jess?
Thank you, Oscar. I sure appreciate the introduction. And I'd also like to thank you and the Farnborough International Air Show for letting us speak at this momentous event. We're excited about the future of space, but we are developing a point-to-point transportation system that is truly revolutionary. It does use space hardware, but it's really just an endo-atmospheric flight vehicle that allows you to fly from point to point within the atmosphere, as Oscar mentioned. And perhaps more important than being able to fly anywhere within 2 hours on the planet is the fact that potentially it can be cheaper than subsonic jets per cargo ton mile, and potentially it can actually have far fewer carbon emissions than subsonic jets burning Jet A. We're basically what we call a boost glide flight vehicle. We take off vertically, boost to a very high altitude, and then we cruise. And the two ways we cruise is gravity drives us, really cheap source of energy, by the way. And also we supplement that with a little bit of rocket propulsion. And that lets us go huge distances. So we can reach a velocity of Mach 10, and we can fly over 150,000 feet, very top of the stratosphere, beautiful view of the biosphere when you look out the window. And we can fly 13,000 kilometers, so a long ways. The high altitude at which we fly allows us to also fly with a very whisper quiet sonic boom. And we'll talk a little bit more about that in a chart or two. But that's exciting. At those kind of altitudes, you don't really hear much on the ground. Finally, our whole company is completely dedicated to a new mode of flight. It's actually the mode of flight invented by the birds before mankind came along and messed it up with the Wright brothers. We take off and land vertically. And that seems a little strange to those of us who have grown up with horizontal takeoff and landing vehicles. But you know, if you drop yourself back 110 years and you talk to somebody out in the street about coming in at 100 miles per hour, bouncing along the runway a few times, and then finally coming to a stop a mile or two downrange, they think you're crazy. So I much prefer, all of us, that with the rockets that give us a thrust to weight of over 100 to 1, 10 times easily better than a typical turbojet, we can come down, easily flare, and vertically land. And we want to make that as routine as can be so that everybody will be comfortable with it in the future. The second thing is rockets fly really high in a really low drag environment. And as a result, you can add a lot of volume to them. And because of the way we fly with rocket propellants, we can actually fly shorter distances with much greater payload. So we wanted a large payload bay. And you can see on the chart, 120 cubic meters is a lot of volume. We can use that for a large cargo space to carry 20 tons over 8,000 kilometers, which is more than enough to fly between Europe, South America, or much of South America, and the United States. We can also use that to support various other missions, from cargo to passengers, and potentially even to VTOL applications associated with dual-use military applications. So the next chart is our hardware. And we're a company that's dedicated and believes that if you're going to do an entrepreneurial venture, you better not be studying the problem. You better be building hardware and testing it. So along the top arrow of this chart, you'll see a lot of hardware for a new class of engine. It's a full flow stage combustion, liquid oxygen, liquid natural gas rocket. And that rocket, we call it Mjolnir after Thor's hammer, will give us a good ISP, but more important, it will introduce the aircraft reliability and operability and safety characteristics that you would normally see in jet engines. So that's our goal. We want an engine that operates with the reliability and safety characteristics of jet engines. And that's what we're building right now. We've got a prototype developed. We've got lots of components, and I don't want to pretend like we're there yet. We got a lot more testing to do, and we're going to build in and test in the reliability and safety features that will let us fly this thing routinely. On the bottom of the chart, you'll see another arrow. And here we've done a lot of design work on an airframe and how we would build it and fly it. But we've also actually built and flown some subscale prototypes. Now, these are electric ducted fan, but they're configured in a way that emulates how we would fly the rocket. And we can take those off and land them vertically, and we do that routinely right now. And we're getting ready to reshape the vehicle a little bit so that we can also demonstrate the full spectrum of subsonic flight. And what this really does for us, if you think about it, it is a subsonic flying wind tunnel that costs a tiny fraction of what it costs to fly in a wind tunnel. And that's not to say we won't use wind tunnels, we'll do both, but we can learn a lot from this as far as how we build and fly this type of vehicle to bring it down, flare, and land. We also have a printed Inconel test article. And again, you're going to have to use high temperature metals for any kind of a system that flies in the hypersonic regime, whether you're going to space or whether you're going point to point. We had done some printing of airframe components and parts, and we can do that, and we'll be able to do it more so in the future. Finally, in terms of testing, we're testing the engines right now. We're doing ignition testing. We're doing a variety of other testing on the components and parts. And we've tested these small electric ducted fan jets up and down. This next chart really indicates that we're really worried about demonstrating aircraft operability and safety from the get-go. And so we've done probably over 1,000 flight simulations of various flight modes and missions that we might fly with this, whether it be out and back without refueling, or whether it be flying 13,000 kilometers, and we got all of them defined and really detailed trajectories associated with every one of them. But there's some unique features that we're going to bring to bear with this type of a flight system. In particular, we want to demonstrate this aircraft operability, but a shirt sleeve flight environment. And that means we're going to have a acceleration when you take off, roughly equivalent to a Gulfstream rolling down the runway at max acceleration. So we're not pulling the high G's you would see in typical launch systems, because we don't have to go as high or as fast. We also are not pulling zero gravities, which Steve can attest to, what we kindly call our suborbital ballistic aircraft that fly those kind of trajectories. We call them vomit comets, because a lot of people get sick, and it doesn't matter whether you get space sick or not, you still might get sick. We don't do that. We strictly go up and we cruise at about 150,000 plus feet. And that leaves us in a 1G comfortable environment for 97% of our flight, with a minor set of G's at the beginning and a little bit of belly bump at the end. Whisper quiet sonic boom. Yes, we are flying so high that we don't hear much of a sonic boom on the ground. And that's a huge advantage to us. It's the FAA standard. When you compare it to what it would be like hearing, it's a bit like being in a quiet suburban neighborhood. So we think that we can solve that problem. And finally, for the last 200 kilometers of flight or so, we're actually subsonic. So we're coming in very quiet at that point, with the barely a whisper of a throttled down rocket. And the last point I wanted to make is we're burning liquid oxygen and liquid natural gas propellant. And that propellant is about the cheapest. It is the cheapest propellants that you can purchase on the planet by far. And so we think that's going to give us a huge advantage in terms of operating these systems cheaply in the future.
frontier aerospace. 2 hours to anywhere on Earth, faster and cleaner than jets.
So I would like to foot stamp one thing out of that video. We are a clean and system that burns very few carbons, as mentioned by our CEO in the video, Bill Bruner. So we have almost no carbon output, far less, as we indicated earlier in the discussion. But more than that, we're using natural gas. So if we go and use a little bit of renewable natural gas, we actually end up with a potentially negative greenhouse gas emissions on the planet. A lot less than any other system, certainly less than Jet A. In fact, natural gas is the only propellant in the world that actually lets you do this, because you're eliminating the methane at its source, whether you're getting it from trash dumps or whether you're getting it from cow farms. And you're also having less carbon emissions during flight. So the combination of that really lets us have a potentially greenhouse negative system, and certainly a greenhouse neutral system in terms of emissions of carbons in the future. So we think we offer an environmentally clean solution for the 21st century. And we thank you very much.
Thank you, Jess. Outstanding presentation as always, and it's great to see every time I hear you present the evolution and the development of the technology coming down from orbital space now to suborbital edge of the atmosphere. And Jess, you touched on the sustainability, environmental elements. If we are thinking about point-to-point transportation, as the air transportation industry is pushing 5 billion passengers per year, the issue of sustainability and environmental care and social gains for the whole world is very important. So I'm very glad to see you've touched up on that, and we'll talk more about that later. And so moving down now to planet Earth, on the surface, the vehicles, whether orbital, suborbital, or in between, are extremely important in technology and flight operation, safety, and reliability. But what is very, very important, and I'm very glad to be on this conversation with the Global Spaceport Alliance, is the infrastructure around the vehicles. A big driver of how feasible point-to-point space transportation will be is going to be measured on the peripheral infrastructure elements around it, whether spaceports, whether airspace, spaceways, whether propellants and supply chains. And to harness all of that, I'd like to introduce our third, last but not least, speaker, Pam Underwood, who is the director of the Office of Spaceports at the Federal Aviation Administration Office of Space Transportation. Pam will give us an overview of how do we go from launch and reentries to launch and reentries with a purpose to have some cross range in the future. Pam, thank you for being here.
Thank you, Oscar, and thank you to Farnborough for the opportunity to participate in this panel and have this discussion. Oscar's right in his very kind introductory remarks. Infrastructure is very important. And for me, as the director of the Office of Spaceports in the FAA, that's a subject that I am always happy to talk about. So as it relates to point-to-point transportation and innovative technologies that will bring that with our industry in the future, I'd like to step back for a minute and just look in the first chart I have here at the cadence. Now, this is launch rates for the United States, what we've seen over the last since 2011. So good, better part of 10 years plus. The launch rates for 2022, by the way, the asterisk is because it's still in work. We're not done with that year yet, but that's what our totals are thus far. But clearly, you see a significant increase in that amount of time. Last year in 2021, we had a record number of launch and reentry activities. The dark blue line is represented the launch, and the reentries is kind of that light blue. So the sum of the two means 60 total launch and reentry activities for the year. That cadence is at least about once a week, maybe a little bit more than that for that number. which leads me to my fiscal year, my 22 number. Believe it or not, it says 39. Gosh darn it, if this chart isn't already out of date. There was one yesterday. So we're actually at 40, but it just shows you how dynamic this industry is. And the launch rates are expected to get to around 68 total, as projected in this chart shown there in yellow. Very, very exciting time. And that is just U.S. launch companies. That doesn't represent a global commercial industry. It's just a snippet of what's going on with the United States companies. So when you amortize this over all the globe, it's a really exciting time because other areas are seeing trends such as we are, which is increase in the interest and activity of commercial launches over the time. So with that, we're going to see some very innovative technologies such as point-to-point transportation. So let's talk a little bit about the infrastructure that's going to be needed. In this chart, again, it's US centric because that's where typically our focus area is, at least for within the FAA, but we are expanding more globally, and I'll talk about that in a moment. But to get started, for infrastructure, it's a very, very, very vital part, as we heard Steve Wolf in the introduction of this. Spaceports are a vital part of our industry. It's really where launch begins. That's what I always like to say, because it's true. The map here on your screen shows the United States launch and reentry infrastructure, where FAA licensed activity is currently taking place. There is other launch infrastructure in the United States, sometimes only used for government, so they're not depicted in this chart. We tend to focus on commercial space in my office, so that's what this chart shows. And I'll show you a little bit. The dark blue locations are what we call FAA licensed locations, so they're hosting commercial space activities. There are really two types of those, horizontal and vertical. The horizontal sites are shown with a little airplane, as denoted with Colorado Air and Spaceport kind of there in the middle of the country. And the vertical locations, I'll just point out on the East Coast, one example, it looks like a little rocket emoji like you have on your phone, but those would be the vertical launch sites such as we see with Wallops Island shown there in Virginia. But that would represent the FAA licensed locations in our country, and you can see we have a number of them. In addition to those, in the United States, we're very fortunate. We also have some United States federal range locations that commercial companies are also using. We see some in California, Virginia, and Florida. And then we also have a third kind of launch infrastructure in the United States, one that we in the FAA call exclusive use. It's a private site that is owned by the company themselves, and you can see those locations there in purple in Texas mostly. But we have a great deal of infrastructure that's ready to support innovative technologies such as point-to-point transportation. Now it's a matter of what else do we need to think about. We've got a network both domestically in the United States as well as globally. I'm working with a number of countries that are putting together spaceports. Some of those U.S. operators are interested in using, so we have the potential for not only a domestic United States network, but also a global network, which has, I think, greater market value for a lot of companies, as we've heard from Steve Lindsay and Jess Bonnable today. The capabilities that they're developing, could be potentially used on a global scale, which is really exciting. So now, we've got the cadence is definitely increased, like we saw in the first chart, definitely increasing over the years. We've got infrastructure both inside the United States, as shown in this chart, and outside. As I've mentioned, other countries are developing spaceports for this type of purpose. Now let's look at a couple other things that I'd like to get into in this next chart. With point-to-point transportation in particular, this chart, I wanted to kind of bin my thoughts about areas that will be needed to consider for this type of activity. And the first that comes to my mind, because of where I work, I'm a regulator, we need to think about the regulatory framework that's going to be required. The FAA in December of 2020 published a new launch and reentry requirements regulation. It's what we call our Part 450. This is a performance-based regulation, and it's intended to be able to accommodate any type of activities that the industry has, whether it's a traditional vertical launch or a horizontal or even point-to-point. That performance-based regulation is intended to be able to cover all of them. So we have that type of framework in the United States, but I think what we need to do, if we want to look at global point-to-point transportation, we need to have some type of a regulatory consistency where, if you take off from one location and re-enter or land at another location, you want to be able to have a consistent set of safety assessments and requirements that one operator will have to do to operate in both locations. I think that's going to be really important. As I've mentioned, in the United States, we have our Part 450 regulatory framework. I'm also fortunate to say that we have a great deal of engagements with other countries that are developing space regulation. So hopefully we, between governments, can have that consistent set of regulatory framework that I believe is going to be fundamental to enabling that point-to-point future coming forward, especially on a global scale. The second category I wanted to talk about, once we put regulatory framework aside, is again back on infrastructure. And my previous slide did focus on, what we have in the United States, but I think what we need to look at, because I do believe point-to-point on a global scale is really where it becomes really valuable for the companies involved. So we need to have a global network of spaceports. And I've mentioned that, my office in particular, Office of Spaceports, is working with a number of countries developing spaceports. We need to keep doing that because not only do we need to have the awareness that the others are working on, we need to have some interoperability between these spaceports. So whether it's equipment connections or services that some of these companies like Jess and Steve Lindsay might need, we need to have some of that interoperability. Interoperability is promoted by that consistent regulatory framework I just mentioned, but it's also very critical to not lose sight of the infrastructure that's needed. So we want to have some common interfaces, or maybe there's a standard set of infrastructure that companies will need, but we should have that kind of global discussion to make sure that our infrastructure, the network of spaceports that we have put forth for this type of activity, is really ready to do it. And my last, sub-bullet in that point about infrastructure is, what are the requirements as these new technologies, like I mentioned, we're fortunate to have Steve Lindsay and Jess Bonnable walk us through their technologies, and they laid it out. But we need to kind of get our arms around the industry and what are their infrastructure requirements, because that way we can start to work towards that interoperability so that there is common interfaces and services and capabilities on that global scale to be able to host this type of activity. And then the final bin that I have here, I'm calling operational readiness. It's a bunch of things mashed together, as you can see from my sub-bullets, but it's critically important. We can design really, really great vehicles that are capable of going point to point. We can have infrastructure, like I said, that's a network and supports that point to point. But without that operational readiness piece that I'm mentioning, all of that becomes really not able to be utilized in the fashion it's envisioned. Airspace integration is key. I think we're going to have to work very closely with our friends in the ANSPs and the navigation providers to figure out how do we integrate these point to point into those air traffic, and how can we have the two coexist is a really good way to say it. And that airspace integration piece, I think, is a tough one, only because the details that are required to work out the operations. So it's great if we have a concept to go start talking with our friends in the aviation, airspace management realm, but we need to have a great deal of operational details so that we can start to deconflict and manage those two, the aviation and this proposed point-to-point transportation consistently. So that's a really important one as far as operational readiness, is airspace integration. I also don't want to lose sight of airport integration. If they are going to be a horizontal type takeoff and landing in another location, a lot of times what we have in the United States is that coincides with an airport. And there are airport operations and airport infrastructure and airport things that need to be considered so that we can integrate those, not only just the ground-based preparations, but even just the operation of utilizing those runways for these pieces. We need to make sure that we're working through those airport integration pieces for what I'm calling the dual-use spaceports, when they're both an airport and a spaceport. I think that's critical to not forget about in that operational piece. And then the final one here is kind of more of what I'm calling transportation procedures. Right now, we haven't really had to think about this for space. But if I were today, I live in Florida, go to the Orlando airport to get on an airplane flight to go from here and pick the destination, maybe to London or maybe to Tokyo. There's a procedure for me to go through that involves security and checking of cargo, and we don't have those kinds of procedures today, at least as a government, as it's applied to space. So I think we need to think about, and that probably isn't a first order consideration, but it's more as the industry evolves and starts greater utilization of this point-to-point network that we're trying to establish. What are some of those procedures that we need to have in place that will help facilitate that? I think sometimes we take for granted how well evolved some of those procedures are for aviation and the aviation air traffic, but less involved and developed on the space side. So I only put this as a transportation procedures. That's something to think about that I don't believe we want to lose sight of as we start to try to grow and make this network evolve into the future. But I thank you for the time, Oscar, on the panel, and I appreciate it, and I look forward to the question and answer session coming.
Thank you very much, Pam, and thank you very much for that last slide. You touched on many things that are critical for the roadmap to evolve from demonstrations of launch and reentries into the proliferation of mode of transportation in the future. If I could summarize what you said, the word safe and integration. The safe integration of a new modality of point-to-point is where we are going. So let me open up the floor now for Q&A. I have a few questions for all of you, and we have about, looking at the clock, 8 to 10 minutes. So I'll try to focus on the high-level questions that can give the audience at Farnborough International, a very wide audience of aviation, aerospace, and space now, a big picture of what could be a roadmap, what could be a crystal ball from this panel, this conversation, into where do we go from launches and reentries into future point-to-point transportation. And I'll start with you, Steve. You've flown, launched, and re-entered safely many times. You are looking at advanced design, starting with cargo visits to the orbital reef and the orbital stations. How, Steve, in a very high level, would you visualize progression between launch and re-entry, maturity, transition into point-to-point industry?
Yeah, so it's an interesting question because we're kind of orbital focused, as you know, with our vehicles, and Jess was talking about what they're developing, which is something that runs around Mach 10 or so. We're running Mach 25, so we're going a lot faster, and as a result, we could turn around on our very first flight and go suborbital point to point if we wanted to. Just cut off the rocket engines a little early, maybe Mach 23 instead, and we could simply drop in point to point. And to what Pam was saying, though, the integration into the airspace, whether the international airspace or national airspace, is a little different with us because we're mostly a vertical trajectory coming in, whereas what Jess was talking about is since they can go subsonic, they can enter the airspace after they're cruising more like an airplane does today. And so you got to think about the integration. But what I really think about when I'm thinking about, because we think about this all the time in my advanced programs group, is what does it look like for us to evolve to, given where we are right now with Dream Chaser? And one of the fundamental market questions I think we have to answer is, based on the size of the world, when you talk about suborbital point-to-point, what's the right speed to go? Because that has very significant implications into the design of the vehicle, the energy required to get there. In other words, do we need to do suborbital point-to-point at Mach 25, or do we need to do it at what Jess is talking about, or Mach 10? Or, there are companies out there looking at what I would call low supersonic to higher supersonic to low hypersonic, Mach 3, Mach 4, and then on up to, scramjet level type stuff, which is around Mach 10. And so for me, it's for us really looking at not just integration of system, but what's the next evolution of this and what is the right speed based on the needs of the customers in the future as we go forward. So it's almost more questions than answers I have at this point.
Thank you, Steve. And that the common factor on that roadmap for all the possible answers, and nobody really knows the answers. There are a lot of trade-off studies, distance versus speed. One thing we know is that people want to fly. The passenger transportation industry keeps growing, projected to reach post-COVID or pre-COVID levels by the end of this year. People want to go places. People want to move their goods places, and sometimes very, very fast. So the appetite is there. We need to cater to it in a safe, integrated, and economical manner. And so I'll move on to NFA and just Spawnable. I appreciate very much your comments about the level of care for the payloads and the level of care for the passengers that will be using your vehicles. And in a way, we have a very high bar of standards when we look at subsonic air transportation. The safety, reliability, efficiency, and sustainability levels are very high. So Jess, I would like to ask you, how do you, on your technology and your vehicles, how do you couple the environmental and regulatory standards that you see on your air transportation parallels? How do you stay ahead of possible environmental sustainability surprise to you as you develop your technology? My belief is that we have to equalize. We cannot have a high-speed industry that is less sustainable or environmentally friendly. Can you say a few words about that?
Yeah, absolutely, Oscar. We are using space technology, but we really are flying in the existing airspace environment. It's just that, 98% of our flight is far above the altitudes where anything flies, unless there's UFOs out there. That's the only exception. And the occasional time when Steve flies one of his vehicles through this environment. Other than that, that's where we cruise. So in some respects, it's an unregulated area, and we do need to understand how we fly in that area. And we also need to understand how we fly up to it and how we fly back down. But our company believes, and all of the founders are absolutely convinced that the way you do that is you build a vehicle and you fly it a lot. And to make Pam's world just a little more complex, we think you can fly out of any airport. Yeah, we have noise considerations that we need to worry about, but there's lots of ways to address those. And so we think we can fly out of any airport. And to the extent that the Global Space Alliance and the FAA can help us understand how to do that using the existing spaceports, great. But I don't want to be limited to the spaceports. I want to fly out of San Francisco. I want to fly out of Los Angeles. I want to fly out of anywhere. And when I'm flying some billionaire on a business jet from point A to point B, I want to land them at the factory. I don't want to go through Tokyo. So there's lots of opportunities for a massive change in how we do business in the future. But we got to learn how to build these rocket-based systems that can fly with the safety and the reliability standards of aircraft. And there's only one way to do that, and that's flight hardware. And so, part of our plan is to build what we call a small Pathfinder vehicle that'll fly to about Mach 5. It is amazingly small, not much bigger than the little electric ducted fan jets that I showed you. And we're going to fly a lot. And we talk about flying 3 times a day. I got to tell you, Pete Conrad, the Apollo 12 and Skylight commander, when he was flying DCX back in the early 90s, that was his big push. He said, we need to fly 3 times a day with this vehicle, and we need to show we can do it. And we didn't quite get there, but we did fly twice in a day, or almost a day. And that's the way you're going to do this, is by flying a lot.
Absolutely.
And absolutely. Now, Pam, how are you going to support us?
Yes. Okay. So you're prepared for the future and to parallel air transportation. One last question, and this is to Pam. Pam, we understand launch and reentry, the regulatory environment, the FAA your office leads, encourage, facility, promote, but safety first. That's brilliant. But when we talk about point-to-point, there are some dimensions that probably will require new agencies involved, multi-agency efforts. And if you could say a few words about the new development, in addition to working with GSA and trade organizations and promoters, how is this multi-agency need to enable point-to-point transportation going to play in the future?
Well, I've got good news, and I never like to say bad news, but good news, and we'll just say other news to that question. I think the good news is when the FAA was established, when the Commercial Space Launch Act was established and first passed in 1984, we were set up to be a one-stop shop. So you don't have to go to multiple agencies to get the approval. However, keep in mind the approval we give has to be within our authority, and I'll explain that in just a minute. So to get the licensing needed, you need to come just to us. And to answer Jeff's question too about how do we support the multiple activities, that's where our Part 450 comes into play. You know, you get approval for all the trajectories you want under your one license, and that's great. You've got the approvals you need. Then you just have the reporting requirements so that we can keep tabs of your launch activity, but those are details we can work out. So I'm happy to say our new performance-based regulations, I think, will suit the industry in this area, even at the launch frequencies that Jess and potentially even Steve would like to have, which is great. But there are other agencies that will be involved. So even though I mentioned that, hey, good news is we're a one-stop shop, that's only within the bounds of our authority to issue the license. You know, I mentioned there could be potentially some security requirements depending on where you're taking off from and where you're landing in. You know, Homeland Security isn't really an area that we've dabbled in, but that is something that's been proposed in the future potentially for space. So we'll have to watch how that goes. But regardless, space companies now are presently working with Department of State on ITAR issues. So if you were to, you know, take off from the United States and land in another country, we need to make sure that there's agreements and those types of things are for ITAR considerations for MTCR countries. I believe our industry is fairly familiar with that, but that would have to become more routine as the variety of takeoffs and landings and locations are taking place. So that type of agency approval would also be necessary, and those types of approvals are done through Department of State. It should also be noted about spectrum licensing. So depending on the types of frequencies that are needed and the types of cargo or payloads or activities that are contemplated, we'll have to think about spectrum licensing. So that would be the FCC for our commercial industry. And then depending on where the launch originated and who owns the receivers, it might even be other countries involved as well in the spectrum. Exactly. So we'll have to work out those types of intricacies as well. But those are a couple that come to mind, Oscar, about what other agencies might be involved. But I think those are all definitely things we can work through. We just need to make sure we engage them to make sure they're part of the conversation.
Absolutely. We need a full track, couple of hours to continue with this. I'd like to thank you so very much for your answers, insights, and touch on reality. I'll summarize safe, sustainable integration as my takeaway on how we make this industry a reality in the next couple of decades. And I'll pass it on to George Neal, a newly minted astronaut who has also been up there and down safely. George, the floor is yours for wrapping up thoughts.
What an outstanding conversation. Thank you so much, Oscar Garcia, for moderating, and Steve Lindsay, Jess Sponable, and Pam Underwood for some excellent presentations. If you've enjoyed this discussion and you're around the air show in person, let me encourage you on Wednesday, July the 20th, to stop by the Space Theater in the Space Zone for a final wrap-up session on point-to-point transportation. It'll provide a top-level perspective, reflect on some of the things you've heard in these two virtual sessions, and allow for lots of audience participation and additional questions and answers on this very exciting topic. So thanks to all of you for participating in the session today, and look forward to seeing you again soon.